This one, the part A looks harder than it actually is, but it's not so bad. Whoops. So if we take a look at A, that's not what I wanted. We have a function f has the derivative of all orders at x equals 0. Let p of x denote the nth degree Taylor polynomial, or p sub n of x, about 0. So it's a Maclaurin series. It's centered at 0. It is known that f of 0 is equal to -4, and that the first degree Taylor polynomial is equal to -3 when you plug in 1/2, show that f prime of 0 equals 2. So my first thought is, wait a minute, maybe I can use the Taylor series formula for this. And so I just started looking at this, and I thought, okay, well, the first part, when I plug in 0, I get just regular f. A is the center, so A is 0. And I need to figure out that part. Well, n, remember n is 0, so 0 factorial is just 1. So then we have -4, because it tells us that. And then f prime of 0, that's the next part in this expansion. That's what I'm trying to find. So there we go. So when n equals 1, that also gives me an x value, which means I will have the first degree Taylor polynomial. So I'm just going to start writing this out. So t of x starts to be first -4, because I would have x minus 0 to the 0 power, so that just goes to 1, and this also goes to 1 when I plug in 0. So that's for n equals 0. And then the second part is f prime of 0. I don't know what that is, but I'm going to figure it out. And then times x minus 0 to the first power, all divided by 1 factorial, which is just 1. So, and then like onward. But this is also the first degree Taylor polynomial. This is p of 1. So if I plug in 1/2, I already know that that's going to be -3. So it's really easy. So all I have to do is solve for f prime of 0. And then I get what? 1 equals f prime of 0. Oops, this is 1/2. Because I'm plugging in my x value. So then this is okay. So f prime of 0 equals 2. And that's what it said to do. Show that. Okay, done. Easy. Okay, part B. It is known that f double prime, so I'm just going to continue this work, f double prime of 0 equals -2/3, and f triple prime of 0 equals +1/3. Find P3. So that's the third degree Taylor polynomial. So I'm going to continue out stuff. Okay, it's not so bad. Instead of writing f prime of 0, I can now write 2, and then x, right, because that's that part. And then the next part is, well, the next derivative, f double prime, so -2/3. That's that part of the formula, because I'm plugging in 0. This is 0 factorial, 1 factorial, 2 factorial. So I have to divide by 2. So I'll just put a 2 on the bottom there, and because 2 factorial is just 2. And then I need to multiply by x minus 0 to the 0, 1, 2 second power. So this is squared there. And that's the second degree Taylor polynomial. So I'll just keep going, and I'll simplify in the next step. The next derivative is 1/3. They give that to me. And then 0, 1, 2, 3 factorial. So 3 factorial is 6. And then times x minus 0 to the third. So I can just write this down. -4 plus 2x. What is this? Minus x squared over 3 plus x cubed over 18. And that's it. So far, so good. This is actually worth 3 points. Like, just using that formula. It's crazy. The first one was worth 2 points. Amazing. You get 100% on this. Part B is done. That's P3. Okay. Part C. The function h has first derivative given by h prime. Ooh, is f of 2x. Nice, very nice. It is known that h of 0 is 7. Okay. Find the third degree Taylor polynomial for h about x equals 0. So, again, I'm going to use that formula. Very nice, very nice. This formula is very useful, huh? So the first thing I want to do is write h of 0. Well, they give me that, because I'm just writing down derivatives. H prime of 0, that's the same thing as f of 2 times 0, right? Maybe? I'm fairly certain. Because they tell me that the derivative of h is the same thing as regular f. That looks weird, though. Maybe that's better. Okay, so that's just f of 0. Okay, what's f of 0? That's negative 4. Great. What am I trying to find? I forgot. Find the third degree Taylor polynomial. So I need 4 derivatives? Yes. So double prime of 0 equals f prime, right? If I have h, well, I already know that part. So then h double prime of x, I should write this down. Maybe you get points for this. H double prime of x equals f prime of 2x. Ooh, chain rule. You definitely get points for writing this down, right? Because I have to do the derivative of the inside. So that means h triple prime of x is equal to f double prime of 2x times 2 times 2. I'm going to simplify it later, but hopefully you understand. I'm taking the derivative of this, so the derivative of the outside with the inside the same. This is just a coefficient. I could move it in front. And then times the derivative of the inside, so I have to multiply it by the extra 2 out there. So this is the same thing. I need to clear this up. So what do I have? This is the same thing as 2f prime of 2x. Oh, this is a fun one. This one's the same as 4f double prime of 2x. And I need the fourth derivative, so the fourth derivative of h is f triple prime, so 4f triple prime of 2x times 2. So that becomes 8. Did I even need to do that? I don't know. Well, let's keep going. Oh, what's that? Huh. All right. So f single prime. So now hopefully this makes sense. H double prime. I can go up here. That's this, and that's the same thing as 2 times f prime of 2. So that's f prime of 0, right? Well, I already know what f prime of 0 is. I had it over here. F prime of 0 was 2, right? Woohoo! So this becomes regular 4. Very good. H triple prime of 0, that is equal to h triple prime 4 double prime. Yeah. 4 f double prime of 2 times 0, which is just 0 in there. So what is f double prime? Negative 2 over 3, and I'm multiplying it by 4, so that's negative 8 over 3. Easy. And now I just put it into the formula. This is so easy. This is, like, it seemed harder than it was. Like, so it's so easy. So what do we get? I need the third degree Taylor polynomial for this. That would be, well, first 7. So maybe we'll I don't know, t of 4. 7, and then the next one, minus 4x minus 0, that's just x, divided by 1 factorial, because I'm still using the Taylor series polynomial formula. I'm still using this. So that's the second term, and then plus 4x minus 0 squared divided by 0, 1, 2 factorial, which is just 2, and then minus 8 thirds x cubed divided by 0, 1, 2, 3 factorial, which is 6. Technically, I could leave it like that. But there it is. So easy. So easy. This is definitely an important formula to remember. That's how you build Taylor polynomials. Pretty sweet, guys. Alright, see you later. I can't even see right now.